All right, we are moving on to topic 2 today. We're going to be covering 2.1, which is conditional statements and inductive/deductive reasoning. So this chapter is when we're going to start to get into our proofs. So definitions are going to be important here, how you phrase things. Eventually, you are going to get a vocab sheet. I'm hoping to have that available for you for next class. That'll be on Canvas. I recommend that you print that out or save it to your computer or have it somewhere safe because it'll be important as we go into this chapter more. So first thing, a conditional statement. That is a logical statement that has two parts, a hypothesis and a conclusion. Now, today's class might seem a little bit almost closer to like an English class than an actual math class, but that's because now we're getting into more of the reasoning side of mathematics and geometry. So, I mean, not all math is just setting up equations. So this is, using some different parts of your brain here. We will have some writing to do. But phrases like hypothesis and conclusion should sound familiar to you probably from science class. So in math, I don't know if you've noticed yet, but we kind of like having abbreviations for things. So instead of having to write hypothesis all the time, we use the letter P. So the letter P stands for hypothesis, and the letter Q stands for conclusion, and that actually comes from some Latin phrases. You don't need to worry about why, just use your abbreviations for this situation. When a statement is written in what's called if-then form, the if part contains the hypothesis, and the then part contains the conclusion. So if I say, if it is sunny outside, then we're going to the beach. That is an if-then statement. My hypothesis is it's sunny outside. The conclusion would be we're going to the beach. When you write an if-then statement, you'll often see, because it is the hypothesis part, which is P, and then the conclusion, which is Q, you'll often see that written as P, arrow, Q, like that. A negation. So negation, think negative. A negation of a statement is the opposite of the original statement. The symbol for negation is just a squiggle. So this means like not P. So not your hypothesis. If we wanted to say not our hypothesis, then we would write squiggle and then the letter P. So a negation, my original if-then statement that I told you is, if it is sunny, then we're going to go to the beach. The negation of that would simply be, if it is not sunny, then we are not going to the beach. So it's just making it the opposite, putting a negative in it. So we have a few different types of conditional statements. And what these do is they kind of switch the order around on things, and they're used in different situations. So our original conditional statement is if P, then Q. If our hypothesis, then our conclusion. And our shorthand for that is P arrow Q. So what we're going to do is talk about the inverse, converse, and contrapositive. And what happens here is some of our orders switch around. We're always going to have our hypothesis, which I'm going to highlight in yellow here. And we're always going to have our conclusion, which I'm going to highlight in green. But sometimes the order is different. So for our first statement here, this is called the inverse. Inverse is just like our negation. So an inverse is if not P, then not Q. If not our hypothesis, then not our conclusion. So in this case, everything stays in the same order, but our hypothesis was negated and our conclusion was negated. And since it's a negation, we have to use our squiggle when we write this down. So this would be squiggle P, and then our arrow, squiggle Q, and then our arrow. And sometimes people think my squiggles look like N's. They're squiggles. I'm just not great at drawing a squiggle. Okay, so this means not P, then not Q. Converse. Converse means reverse. And I would like you to write this down. Converse means reverse. So we're going to take our original statement and we're going to flip it around. So this would be if Q, then P. If our conclusion, then our hypothesis. So if our conclusion, then our hypothesis. So our order switch. So again, if you think back to my first statement, which was if it is sunny out, then we are going to the beach. If you flip that around, that would say if we're going to the beach, then it is sunny. All right, it's still a logical statement, but it's flipped around. We took those and we switched them. Then our symbol would just be flipped around here. We would say if Q, then P. So Q, arrow, P. And then our last one is called the contrapositive. That is our reverse statement, so our converse, but now it's negated. So we're going to say if not Q, then not P. So if not our hypothesis, or if not our conclusion, then not our hypothesis. So if we are not going to the beach, then it is not sunny out. So you reverse them and make it the opposite. And our symbols here, our shorthand would be our squiggle, Q, then our arrow, squiggle, P. So if not our conclusion, then not our hypothesis. If we are not going to the beach, then it is not sunny out. Equivalent statements, that's just when two statements are either both true or both false. We don't do too much with that. I just like you to know the phrase. So what we're going to do here is practice writing things in if-then form, identifying our hypothesis and our conclusion. So this says for 1 through 3, underline the hypothesis once and the conclusion twice. Rewrite the conditional statement in if-then form. We're actually going to do this in the opposite order. We're going to rewrite it first, then we're going to identify because it's a little easier to do it in that order. So you are in Indiana if you are in Chesterton. Now, when we're writing this, if we want to write a conditional statement, you have to think you typically want to write a statement that is true if it's possible to do. So you are in Indiana if you are in Chesterton. Think about if you turn this into if-then form and you said, if you are in Indiana, then you are in Chesterton. Well, not necessarily, right? And take a look at the phrasing here. It actually says, if you are in Chesterton at the second half here. So that's actually going to be the start of our new sentence. So we're going to write, if you are in Chesterton, then you are in Indiana. I apologize for not the best handwriting in the world. It's hard to write small with this stylus. So when you're now identifying your hypothesis and conclusion, your hypothesis is always after if, and your conclusion is always after then. So when I'm identifying my hypothesis here, again, that's the part after if. So that's my hypothesis is you are in Chesterton. My conclusion is the part after then, which is you are in Indiana. To underline it twice. Okay. All 30-degree angles are acute angles. So there's a few different ways you could phrase this, but I'm going to say if angles are 30 degrees, then they are acute. So if angles, or you could say if an angle is, if angles are 30 degrees, then they are acute. Because if you wrote that the other way, that's not necessarily true, right? If you said, if an angle is acute, then it's 30 degrees, that's not necessarily the case. Maybe it's 60 degrees or 45 degrees, right? So again, our part after our if is our hypothesis, and that does not include if, it's just the part after it. So our hypothesis is angles are 30 degrees. Our conclusion comes after our then, which is they are acute. And then last one, 2x plus 7 equals -1 because x equals -4. This is an equation, and with an equation, think about what you start with. You start with, or when you're solving an equation, right, you start with the equation itself. You don't start with the answer. So if we write this as an if-then statement, we would say if 2x plus 7 equals -1, then x equals -4. Again, that's because when you solve an algebraic equation, you start with the equation and end with your answer. So when we identify our hypothesis and conclusion here, our hypothesis is actually our equation, and our conclusion is our answer. All right. For this next part, we're going to be writing all of our different kinds of if-then statements here. So conditionals, converse, inverse, and contrapositives. And then we're going to identify if they're true or false. So this says let P, so that means let our hypothesis be you are a guitar player. So that's going to be our P, our hypothesis is you are a guitar player. And let Q, our conclusion, be you are a musician. Write each statement in words, then decide whether it is true or false. So our conditional statement, that's just our original if-then statement. It might help you when we're doing these to look back up at your chart because those symbols really help you figure out your order. So a basic conditional statement is if P, then Q. If our hypothesis, then our conclusion. So if you are a guitar player, then you are a musician. And we're going to decide if that is true or false. Now, how true and false things work is if it's ever false, you just say false. Okay, so if any situation. But if you are a guitar player, well, that means you're playing music, and that makes you a musician. So this statement would be true. So at the end here, we're just going to put a T for true. That is true. If you are a guitar player, then you are a musician. Converse. So take a look up at your chart here. Converse, that's the second one. That means reverse. So this is Q, then P. If our conclusion, then our hypothesis. So we're going to switch our order this time. This would be if you are a musician, then you are a guitar player. Well, think about it. Just because you're a musician, does that mean you play the guitar? Not necessarily. Maybe you play the drums. Maybe you play the saxophone. I don't know. But since you don't have to be a guitar player, this situation would be false. Because there's other instruments you can play and still be a musician. Then inverse, look back up at your chart. Inverse is the negation of our original statement. So not P, then not Q. Remember, the squiggles mean not. So we're just going to take our original statement that we wrote and negate it, put nots in it if you are not a guitar player, right? So if you are not a guitar player, then you are not a musician. Okay, so let's think about this one. If you are not a guitar player, does that automatically mean you can't be a musician? That would be false. Similar situation up above, maybe you play something else, right? You could still be a musician. And then the last one is contrapositive. Look up back at your chart. A contrapositive is if not Q, then not P. So if not our conclusion, then not our hypothesis. We're going to take this statement and flip it around. Let me go up so you can see the hypothesis and conclusion. So if you are not a musician, then you are not a guitar player. This would absolutely be true. Because if you're not a musician, then there's no way you are playing the guitar. Okay? So that's it for this video. In the next one, we're going to talk about some definitions and some biconditional statements and do some examples with those.